that, we can go ahead and get started with some questions. Did you have a language that you preferred?
Yeah, can I use Python?
Sure, I can switch that over. Or I guess you can select between two or three. Cool. So the first question is pretty short. It's just basically you end up having a robot on an MXN grid. It starts off at the top left, and you want to find out, given that it can only move down or right, how many ways can I get to the bottom right corner? So there's the actual question. I'll paste in some examples.
Yeah, I think I solved that problem recently on LeetCode. It's I can give you the approach, I guess, or
sure. And if it's like right on, we can do another question.
Yeah, it's a dynamic programming. So basically, you keep track of, so every time you move to each cell in the grid, you use your left and up numbers in your memorization array, and you just add them until you go to all the way to the bottom right.
Yeah, that sounds pretty much about it. The only thing is, I guess you have to handle the initial top row and left row, right, or left column. Cool. I guess given that this is really recent, I can pick another question.
Okay, cool.
Let me just paste this in. For this one, I'll just let you read over it.
Given a set of candidate numbers. That must not contain duplicate combinations. So example 1, 2, 3, 6, 7. Target is 6. Solution set is 7, 2, 2, 3, 4, and 3, 7. Yeah.
Right. So because we didn't do the last one, we can actually kind of do this question in two parts. Let's say that in the beginning, the condition that you can pick the same candidate an unlimited number of times, let's say this doesn't exist. So it doesn't exist. Portion on line 5. Let's try to solve that first.
So you cannot use the same candidate number.
Yeah, we can go with that, and then after finishing it, we can add the condition back in.
Understood. Okay, so in the example 1, the solution would not include the line
20. Yeah, you wouldn't have line 20 just because you used 2 multiple times.
Okay, and you're returning all the possible combinations out there, right?
Yep.
Okay. Example 2, 2, 3, 5. Okay, I guess the 29th is the only possible.
Yeah, the 3 and the 5.
Okay. And what if the input has duplicates, or that's not possible? Okay.
So yeah, if you won't have that because it's a set.
Also, then there's only one possible combination, right? That would equal the target.
I guess that is true. Yeah.
Okay. And it's all positive numbers, and target itself is also positive. Okay.
I don't know if that condition exists, but let's go ahead and say it is.
Oh, it does on line 12. It says all numbers, including target.
Okay. Sorry, I missed that.
Okay, just to make sure. Okay. Is the input given in like sorted, or it could be where it's not sorted?
Let's say it's not sorted.
Okay. Okay, so yeah, basically approach, I guess, would be something like, you start with okay, so one approach is obviously, sort the array, and then um, create, so let's say, for example one, um, you have to, you keep track, let's say you keep track of a sum at every iteration. So the second time you have 5,
Okay.
then you have 11. 11 is greater than 7. So um, that's not the right, you cannot use more than, you cannot use 2, 3, and 6. So you have, let's say, 2 and 3, 5, and then you keep going with 7. That's, that will be more than 7, so you can't go with that either. So then you start with 3, um, and then you say 3 plus 6, 9 is greater than 7, so that won't work. You include 7. So I guess the brute force is, just go through every single possible combination out there to get the target, and once you find it, just return it.
Yeah, that is what you do, but from your description, it sounds like you kind of have like a window. So if it's, say, 10 is the target, right?
Mm-hmm.
Uh, you would include the 3, and then I'm assuming you would try to include the 6, but then afterwards you want to not include the 6, right? But you still want the 3.
Right. So yeah, in case of sorted, um, yes, in case of sorted, you're looking for a window basically. So you have 2, right? 2 is
Okay.
less than 10, so you keep going. You include 3, 5, and then you go for 6, which is 11. Now in that case, you reduce your left, um, or you increase your left index, so it goes to 3 and 6, which is now 9, which is still less than 10. You
Okay.
include 7. 7 is greater than, 7, 6 plus 3 is 9, plus 7, 16 is greater than 10. So you remove 3 and you have 6 and 7.
Right. Now you're over. So it seems like the window idea doesn't really hold, right? Because for
Right,
here you want 3 and 7 and not 6.
right.
But you were saying going for brute force. What would, that be if we were to just brute force this?
Yeah, so if you have a sorted array, right?
Hmm.
I mean, even if it's not sorted, you can just you can, let's say you just basically go for every single combination, right? So in this case, you start with index I equals 0, and you go for, so you say 2 plus 3, which is 5. You keep going 6, so you include all the numbers starting from 2. Um, so you have 2 plus 3, 5. Keep going, plus 6, 11. 11 is greater than 10. Any number you include after 7, or 6 would be greater than 10. So you go to the next, you start your new index I equals 1, 3.
Okay.
And then at 3, you have 3 plus 6, 9. 9 is still less than 10. So you include 7. So 7 is, well, that would be 16, just greater than 10. And uh,
Okay. This still sounds like the window option. It's not totally brute force, right? Let's say it's not sorted. So let's say you have 7,
yeah.
3, 2, 6, right?
Hmm.
So at each step, what are your options? You said that you're trying to build up towards a sum. So what does that really mean, right? When you're looking at each of the numbers, you said it's all combinations. So
Right. So I mean, one way
uh,
is you can generate all the combinations, right? So you have a combination of 7, 3, 2, 6. So you have 7, 3, 2, 6, and then you have 7, 3, and
yeah,
7, 3, 2, like that. And then once you generate the combination, just for each combination, you compute the sum, right?
right. And if it matches the target, then it's totally okay. Yeah, like that does sound like a brute force solution to me that
Hmm.
works out. Um, cool. So I guess what is the complexity for that approach?
Um, well, you're going through every single combination out there. So I guess, um, not sure exactly what the formula is, but it involves something to do with factorials.
Okay, what makes you say that it's factorial?
Because you're trying. So in the first case, you have, since you have um, one, so you have four elements in this case. So you have at least four single elements, right, for combination, and then for each element you have um, just trying to think how do I word this. It's sort of like branching of it's like, so you have n elements, right? So you find the
Okay.
combination of n minus 1,
Yep.
and then you have n minus 1 itself plus n times n minus 1.
Okay. I see. And you're saying
So
that that's the kind of that matches how the tree would be structured. Okay.
mm,
Sure. Uh, let's go ahead and try and code this out, and maybe we can come back later on to the space complexity.
okay, sure. All right. So I guess when we're, I guess, just thinking if we can do, we can find the combination on the fly itself instead of generating all the combinations first and then computing the sums. But I think that's not possible because in order to create those permutation, you still need to go through all those things. So I guess I'll just start with creating a combinations first.
Sure.
So combinations of, you know, uh, well, nouns, for example. So in this case, the general approach, like I said, was something like you can use a recursive solution in this, which is you find the combinations of n minus one. So let's just say go the base case first. If it's empty, if your list is empty, you can just return it's an empty. There's no combinations, right? If the length of the length of numbers is less than two, just one actually. In that case, you return so the combinations are and empty list, right?
Okay.
So yeah. Um, and now if you have anything greater than two, you first find the combinations of um, n minus one, or just previous combinations. That would be combinations of nums, 1, 2. So this would, get me all the combinations. So let's say, for example, you have,
Thing pretty much without the, 0th element, right?
right? So if you have something like this, the combination for 2 and 3 would be what should give you something like 2, uh, 2, so empty list, 2, 3, 2 comma 3, right? That's your n minus 1 or without the
Okay.
first element. And now um, you keep that combination and you send it to in your final combinations. And for each one of those, you include the first um, element in your combinations. So I guess I can
Right.
do something like rest append. So you have your original, and then you have for each one you have plus plus nums 0, and you just return the rest. So in this case, you have your n minus 1. So you include that itself, and you have 1, comma 1, comma 1, comma 1.
Right.
And that should give you the combinations. And for our actual solution, should be the name of the function? I'm usually not good with naming the functions for it as generic as this.
We could just call it match target combinations, or I don't know, something like that.
Yeah, that makes sense. You said match, right?
I mean, really anything goes here. This is throwaway code, right?
Yeah. And you're given nums, right? And you have target. So yeah, once you find all the combination, we just return let's see. So for each combination, you're finding to give it a one, but yes, not. So for each combinations of nums, if target equals some return, we're returning the sum. We're returning the combination itself, right?
Well, all of them. So I guess you depend to some collection.
Okay, right. Okay.
So it's not just returning on the first column.
Oh, we can just do this then. For so that should give us all the combinations.
Right.
Yeah, all the combinations whose sum is equal to the target.
Cool. So I guess given this, let's write some test cases for this code.
So we have 7, 3, 2, 6, right? And the original target, I forgot what the original target was, but let's see 10, right? So this should give us 7 and 3. So this should equal 7, 3.
Okay.
Yes.
Right. So I'm pretty sure the line there for line 55, you can't modify an array and get the loop over it at the same time, right?
In this case, it'd be fine because when you have length of the rest, which is static.
It's just set at the initial call. Gotcha. Okay.
Oh, there's yeah.
Because length of res is being changed, right?
Yeah.
But I guess
Yeah,
that's only
right. I was aware of that. The length of the rest changes as you're looping through, but since
I guess it's
when
only
you call the length of
Got it. Okay.
It still doesn't like that. Still doesn't like
Right.
that.
Basically saying the left one is an int.
Yeah. But it shouldn't be because let's see. So if we have 1, 2, and 3, just have 1 or 2. Let's see. So if you have 1 and 2, for 2 you have so 2 you turn. Oh, I see. Okay. So combination worked. Let's just make sure. Looks correct. 7 and 3 should be there. Sum of that combination.
Yeah, it looks like it's just the other order. So it's 3 and 7 instead of 7 and 3. But for the most part, that does look like the different combinations.
Yeah. This return. Oh, it returns every single one.
No, I think it's just the 3 and the 7. It's printing off comms and then it's printing off the 3 and the 7.
Oh, I see. Yeah, sorry. I didn't realize that. Right. So.
Yeah,
Okay,
it
so
looks
it is
like
correct.
that
Yeah.
one pretty much works out.
Yeah. I didn't realize that the. Okay. Cool.
Cool. So let's just, I guess, go through a couple more test cases before we
Yeah.
extend this.
What else do we want to try? So let's try 2, 3. So if we do have like 5, right? Yeah, I don't know. The order could be, so I'm just gonna print. I don't know what the order has to be. Okay, that sounds right. And if we have something like
But it seems like this one's kind of printing it out twice.
yeah, that's because we decided not to have duplicates, but
Oh, okay, right. But your example itself.
yeah. So I mean, I can modify the code to just not include the like just make the array unique every time, like just get the unique combinations of.
Right. I think the test case itself would exclude the extra 2, but yeah. But either way is probably fine.
Mm-hmm. Cool. Should I go with more test cases or?
I think usually you'd want to check for some of the edge cases, right? Of like
Yeah.
what
So
happens if it's a near empty array or it's a single item or something like that.
Yeah.
You do know that your base cases probably work just because the larger cases wouldn't work as they are, but uh, we can probably check those out in isolation.
Yeah. Agreed. So this should
And
be
then you kind of get, yeah, you get nothing out of it. Right. So I'd say for the most part, this has looked fine to me since the first test case that we did. Let's go ahead and add back that condition from earlier where it turns out you can select an item multiple times.
Okay.
And you can, just copy and paste your existing code if you want.
I'm sorry, copy and paste for what?
For like the extended function, right? If you want to continue elsewhere.
Okay. Yeah, but before I dive into the code, I just wanted to
Think about it, right? Yeah.
think about it. So the combination will give you the combinations, but we may want to include multiple instances of each number in the combination. Guess one way is to pass the target to the combinations function, and every time um, every time you generate this combination, like line 58, right? You check to see if we can include the same instance multiple times, as
Okay.
long as the sum of that number will be less than target.
Okay.
So this way, if let's say if we go for in the line 70 example, right? um, well, in this case, it's two, right? It's 3 and 2. And yeah, and target was 4. So in this case, the expectation of a 2, right? So in that case, you can so when you are creating this creating combination for just 2, you
Yeah.
keep including multiple instances of 2 as long as the sum of that particular combination is less than or equal to 4.
Right.
So if I were to modify this, um, so I would do something like, this is my original. Um, so you have your target passed, right? And how many times do we want to include it? That depends on the sum itself. So target minus the sum of the current combination. So for example, it's 2, right? The current combination says 2 and target is 4. Or let's say target is 6 and current combination is 2. And whatever that number is, you divide that by the current number that you're about to add to the list,
Okay.
and you add that to the number of times, so or the integer division of that. So if target was, let's say, 7, or even if it's 7 minus 2 would be 5. Integer divided by 2 would be 2, so you would include it 2 times. So you would do something like copy times. So this would include this array multiple times, or include this number multiple times.
Okay.
Now there is a problem with the base case, line 54, and they want to do something similar. So in that case, you just do the same thing basically, but the sum itself is 0, so you do target, do the same thing, but sum is going to be 0, so no need to include that. Oh, and the parenthesis here. So I think that will give you your combinations for no. Yeah, that's right.
Right. So one thing that I'm thinking is normally when you end up recursing, you have the option to add to your result either one of a num or two or three or four, and then you'd recurse given those options, right? Because there may be other combinations that involve picking, let's say, a two one time or two times or three times. How would that end up working out with this kind of solution? Because it seems like you add the max number every time you can. So I guess on line 56, I'm not sure if you're modifying target at all when you recurse. I'm assuming you don't. And then afterwards, you just append the maximum, right? Number of times that you can some value. So if you have 8 left that you can append to your target, that seems to be the number that you go for. So you can append 8 twos.
Yeah. So if you have 8 and your combination so far is empty list, then you have 8 twos, 4 twos, yeah. I'm sorry, I wasn't sure if I was actually following what you were saying.
So basically, what I'm trying to say is, let's say you have, let's say 2, 3, 4. There's some combinations which are going to be 1, 2, right? And then other numbers, and then other combinations that are going to be 2, 2s, and then other numbers, and then other combinations that are, let's say, some n 2s, and then it continues. Let's say this is 2, and then you have other numbers, because there could be other numbers that finally get you to your target, right? Does that work out? Does this kind of case work out with this code? It's something that I wasn't totally following.
Yeah.
But it seems to me like you don't recurse it that way.
Yeah, I think so. It won't handle that case.
Okay, so maybe we can think about how we solve the initial problem. So your option was to generate all of the combinations and then just do a filter at the end, right? So what we're really doing, if we think of this as recursion at each step, is you're either picking a number or you're not, right? If we were to structure the recursion in that way, how does this, you are choosing to either pick the number or you're not. Your line 64 is when you don't pick the number, but then the option of picking the number, it can also be done recursively, right, instead of iteratively. And maybe instead of building all the combinations, we can build our answer as we go along instead of filtering at the very end. I don't know if it's easier to think of it that way or not to you.
Right. So I think what you're referring to is like if I understand correctly, you're saying like when you're generating the combination itself, right, in your line 67, you you basically decide whether you want to include the nums as zero, um, if you want to include that into your combination, right?
Yeah.
Yeah, I mean, yeah, we can definitely make that decision.
I was thinking of it more as in getting rid of the loop so that we can also do the case where we, include it a number one time or two times or three times. That part can also be done recursively
Oh, I see.
because this has a mix of a recursive and iterative solution, right?
Mm-hmm. Okay, I see. So it's sort of like you have n minus you have combinations for n minus one that may or may not be um um
Let's say we have a list so the list build up thing that I mentioned, that's only for efficiency reasons. I don't think you really need it, but let's say you had some list that you were building up and you append to this list.
mm-hmm.
You would want to keep track of the sum of this list so that you can compare that to the target in a sense.
Mm-hmm.
And all of your recursive steps would just modify that one list.
Okay, I see what you're saying. So okay, so it's like so you have this list of combinations with each combination with its sum.
So the list that I'm talking about is just one list. It's not a nested list. So there's a single list
Okay.
which includes one build-up,
Okay.
and
And it's
you would have a separate result list, which is your combinations.
okay. And with that single list, you also have the sum at the current, like some of the current elements in the single list.
Uh, yeah. The only reason I'm bringing up the single list is maybe because with that it's easier to think of the entire thing recursively, right, instead of a mix. But I don't think it's required. So if let's say you had inside of your recursive step you had an index, right, as one of the arguments, that is what's used to determine where you are, right, in your process
Mm-hmm.
of generating a single combination.
Yeah, I'm not following the index part. Um,
It goes back to the initial idea, the way of thinking about it that I was kind of proposing is that at each index, the options that you have are you're either including a number or you're not, right? So let's say we start off at index 0. You have the option to either include,
mm-hmm.
Nums of 0, or really
Mm-hmm.
nums of int, right? Into your current combination or not include it. So this is
Oh, okay.
without including duplicates, right?
Mm-hmm.
So if you do that, one of your recursive steps are to recurse including nums of int, and then the other recursive step is to recurse without including nums of int.
Oh, okay.
And
Oh, so I
now,
see.
going through it n times, you'd add nums of int once, and then twice, and then three times, and then four times, up to, until you go too far on the target, right?
Okay, I see. So you're sort of branching off uh, your number of times you call this recursively.
Yeah.
Okay, so it's like so line 80, you have this match combination sum, and yeah, you have this index. You start with zero initially, right? And you So it's like let's include into our, so you have a list of single list uh, with the existing elements, and then you recursively call for each index. You recursively call if we not include it. Um, hmm, I can kind of see how it's made, but I'm not trying to connect the part where um, the recursive function, is it to check or is it to generate? I believe it's probably to generate those combinations.
Yeah,
Uh,
it would be to generate a single combination. Well, it's to generate all combinations, but when you get to the base case, let's say that means that you're done checking all indices, right? So
hmm
that would mean that your index is equal to the length.
hmm
What would you want to do at that point, right? It's up to you.
Okay, I see. Okay. Right, right. Okay, so it's like right. So if my index here is equal to the length of nums minus one, in that case you return nothing, right? It's like you so at every index you call the function recursively, um, not including it, and then second time including it, and then appending to that your result list and returning that list. And every time you call that function recursively, you say go to the next index. Okay, so just like drawing out how it looks like, right? So it's like match comes some the nums, right? Target stays the same. Index index is going to be plus one, so that's not including it. And the second time round, you have same function, um, including the index. So you have a list as current list.
Okay.
So in this case, you have current list plus nums of current index, and you append that to your list. And yeah, I know we can always include multiple of nums index depending on what's not the base case here. So your base case would be, when index hits length of nums minus one. In this case, where you return the current list, right? So this is empty initially.
Okay.
Well, you need some sort of way to check, or let's do like goes to the length of, because we might want to include the last one. We want to include it. So if
Right.
you do like none, and if hmm, if press is none, no, it's not right. can do something like or empty, and this would be something like mm, right.
Okay. I think given the time, we're probably gonna have to end it at that.
Mm-hmm.
The one thing I wanted to ask about, we never talked about the space complexity for, this, your approach. How does that kind of end up going?
Mm. Yeah, so um, since we're branching off the recursive calls multiple times, that would, stack up um, space very quickly, and you have this current list, uh, which um, may not grow as long, like could grow depending on the numbers, because if we include the element multiple times into your current list, then it will grow. Um, so
Oh,
thing this
okay. I was thinking of just the, without the option to include multiple times
okay,
for the thing we finished coding.
right. Well, in that case, your complexity would be something to do. Can't come up with the formula, but it would be something like factorial or like n to the n or something like that, because you're
Okay.
generating all the combinations.
Okay. Sure. So I guess I also wanted to spend some time to just talk about what I was trying to hint at without, totally giving it away. So
Mhm.
normally when you do comms and you have an array, say that you have, a directed comms,
Mhm.
all you need is the index value, right? So you have a result array and then you have a partial array. And what you should be able to do is just call directed comms on the 0th index. And what you say is, if end equals a len of r,
Mhm.
uh, this is where you would do your filter, right? Uh, if it's equal, and if it turns out that sum of partial is equal to target, in
Mhm.
that case, you'd append to the result your partial copy. And
Mhm.
at each step, what you can really do is, either partial.append r of end, and then directed comms on n plus 1, or you don't include it. Oops.
Mhm.
Uh, it's pretty much that, right?
Mhm.
Uh, when you
Um.
include it multiple times, uh, the only thing that really changes is that you're also going to be modifying your target in your recursive call. Because at the step where you decide to, 90, 91, this is only adding one time, right? But you can add 1, 2, 3, 4, some X number of times. So you also end up needing your target in your inner call.
Mhm.
And for convenience, you can probably also include, a current sum, right?
Mhm.
Yeah, I don't know if that helps. This is
So
just
how
one
does it
option.
change directed comms call? So you pass in the sum of the current partial and then comma target minus the element, or
I'm sorry.
so line 91, right?
Yeah,
How do you call it differently? Like how the target changes, you said, right?
yeah.
So what will be your target when you're recursively calling it? Is it like
So
target minus?
your target doesn't change. It's you only needed summed or target. That was my mistake. So
Okay.
uh, over here, your initial sum is 0, so you call with 0, 0. Over here, if it's just a single time, then you would do summed plus r of end, right?
Mhm.
And over here, you would do still summed. If you want to do it multiple times, then I think you could have while, let's say, num pix is equal to 0. I think it's while sums plus num pix times r of ind is less than or equal to target. This is kind of the loop you'd want to do. And then, you would modify num pix plus equals 1. And there's some other stuff you change in there, but it's tiny.
Cool.
It's just the summed portion. Yeah, this is one of the options. I think there's other ways to solve this too, but I couldn't see how you would figure out the multiple branching portion if you generated all the combinations at once. Yeah.
Yeah. Yeah, I definitely could see there's a hole in my approach definitely on that case because you don't know how many times you may wanna include other elements multiple times too. So
Yeah, just because you're generating all of them beforehand. But
right.
I just included the last portion because I thought it might be helpful, but I think overall the first question went pretty well. Are you interviewing at some places currently, or is it just in the future?
Yeah, I mean, probably in the future, but have been interviewing with a few companies recently, so
Gotcha.
practicing.
Cool. Did you have any questions for me?
Yeah, I mean, any fee. I know there's a lot of work I need, practice, in terms of, organization of thoughts as well. I need to practice that a lot. But any feedback that you can provide that would be helpful.
Yeah, I guess part of it is maybe you can direct more of the material yourself. Like I want to say that usually after you come up with a solution, the format that I've heard a lot of people recommend is you go with constraints, ideas, complexity, code, test, right? I think you talked about the constraints early on, which is really good, where you mentioned that it's all positive numbers. Is it ordered or not? The idea for trying to talk about the complexity, usually you can, I want to say maybe self-direct it and say, oh, this is what the space and time complexity is. Maybe some interviewers don't care about it. So usually it's like a very short amount of time, right, to talk about that stuff. I would say that the coding portion was totally fine, but the reasoning for the complexity seemed kind of weak. So
yeah, because I couldn't. I guess it's the memorization, right? I mean, because I couldn't remember what the combination number, the complexity for combinations was.
Right. Yeah, I actually don't know how to entirely analyze this thing with your combinations. To me, it seems like whenever you're calling this recursively, you just have a linear step in the sense that the recursive portion only excludes. Sorry, I'm trying to find where your older code is.
I know it's. I know I need to work on that too. I
think it's 73.
Yeah.
Where it excludes the first item. It's the actual thing. It definitely isn't linear, but yeah, I didn't have much feedback past, I guess, those portions. I thought the coding was fine.
Cool.
That's the main thing.
What do you think about the speed? I mean, I definitely didn't finish the problem, but do you think I need to work on the speed or slow down more, go more into approach, like go over the approach more carefully before jumping into the code, or was it fine?
No, I think you had a uh, good amount of discussion before going into the code.
Okay. Cool.
So any other questions?
I think that's it. So, one more question actually. So, what do you think about so the question you asked me, right? Like, is there a what you would say you would ask this question, or I should expect this question? Um, how do I ask this question? So what I'm asking is do you think this question is more for new graduates or like people with more years of experience? Who would be the appropriate audience for this uh, question with this kind of difficulty?
Right. So this, I guess, if you've ever used LeetCode, counts as a LeetCode medium
Hmm.
in terms of difficulty. I
Okay.
would say it's definitely there.
Okay. Yeah, thanks so much for your time, and the feedback was really helpful, and I think the question was really good too. Kind of was challenging, and that's what I wanted.
All right. Sounds good. Thank you, and have a good rest of your day, and
All right,
best of luck.
you too. Thanks a lot.